Hey, what's up, guys? Welcome back to another stream. This is day 35 of Intelligence Maxing. So, we've made it past a month, and today I have a few assignments I want to get done for class, mostly having to do with a lot of these write-ups. And the one I'm probably going to do on this stream is the write-up about hedge fund incentives. So, there's this paper that is written by some pretty smart people called High Watermarks in Hedge Fund Management Contracts by, I think, Henry Goodsman. I don't know what the first names of Ingersoll and Ross are. These guys wrote a paper about how to kind of value and think about hedge fund contracts, specifically the incentives and structures for those incentives that limited partners might set up. Big takeaways so far seem to be that there's usually some type of high watermark structure set up so that these hedge funds, they only... Actually, let me take a step back. So before I even talk about high watermark, usually hedge funds have two types of fees with their limited partners. One is kind of this overall management fee, and then the second is a profit fee. So if hedge fund makes, let's say, 20% return, they might get 20% of that 20% return within a given year. But then there's the idea of a high watermark where the hedge fund needs to go above and beyond a previous high point within the fund itself in order for the actual percentage profit to kick in. So that can kind of prevent hedge funds from making really riskier investments and also making questionable decisions in order to try to arbitrage away their profits and their incentive fees, I guess. And so the first question that we need to ask ourselves, I think, is a brief summary of what this paper says that might be of interest to potential limited partners in hedge funds, such as Harvard or Yale. I think some interesting things that this paper kind of wrote about was when you're thinking about the hedge fund industry versus the mutual fund industry, there's differences in the size of the funds itself and the different strategies that are incorporated. A lot of hedge funds are engaged in arbitrage strategies, and these strategies usually involve a lower amount of capital than traditional long-only mutual funds. So what you'll see is a lot of successful hedge funds, instead of growing their assets under management, they actually restrict new people from investing in the fund itself, because having more capital might mean they have higher price impact, and higher price impact might actually... How should I say this? Having a higher price impact might nullify their actual arbitrage strategies compared to a long-only investor where usually a lot of investors flock to high-performing mutual funds and they grow their assets under management kind of artificially by attracting new investments. So I think that's one of the big things. And there's another part I believe I wrote down here, that the actual fees paid for hedge funds depend on the volatility of the underlying portfolio and the probability that an investor will exit the fund. So I can kind of understand the volatility part, where having a high volatility portfolio might cause the actual returns to be higher, which could cause the profits portion of the fees to be a bit higher than the, I guess you could say, just fixed annual fee. But then you have a short-term life expectancy. I'm not too sure why the short-term life expectancy will cause a high watermark fee to be expensive, though. Oh, damn. then you can also say that for the opposite case where the general management fee, so this is the fixed percent of assets under management, will be higher if there's low volatility in the portfolio. So this is kind of where we talked about the hedge fund's return diminish with size. And then here on this question, we try to replicate the model that the authors wrote to find the value of the contracts, specifically the value of the fees, the present value of the fees. And this part is kind of where it gets really mathematically heavy and challenging. Some of the stuff, I'm going to be honest, I have no idea what the hell they're talking about. But I just kind of copied some of the formulas and equations that they have. They have, I think, 3 different important models to look at. One is to calculate the present value of fees, which I coded up here. And then the second is to calculate the present value of the performance fees. And then you can subtract the total value of the fees minus the present value of the performance fees, and then you'll get the remaining fees left over. So the remaining fees will be the annual fee. And I think they make a few assumptions here, and the model itself, I guess the mathematical formula, depends on a few different variables, I believe 9 different variables. And then they go into this weird digression into actually proving and deriving the equations. I think that's beyond the scope of my knowledge. I've never taken a class on partial differential equations, and they start talking about some random ass stuff. So if I have the time, maybe I'll take a deeper look. If not, then I'll just leave it as it is and then try to just use the models that they provided to run through a example scenario. I think that's really the main thing I need to do. So what I'm going to do now is probably restructure this paragraph so that it's not just bullet points but more cohesive. All right. So this is kind of what the introduction of a high watermark refers to. So the authors of the paper suggest that hedge funds are different from traditional mutual funds, and that returns tend to diminish with size due to the underlying strategies of arbitrage strategies. Successful hedge funds are usually closed to new investors. Wow. Successful hedge funds are usually closed. The opposite is true for successful mutual funds. Okay, so successful hedge funds are usually closed to new investors, while the opposite is true for successful mutual funds. Likely reason is that higher capital might dilute the how should I say this? The most likely reason is that the strategies of these hedge funds I think the most likely reason is that strategies of these hedge funds. So hedge fund strategies try to take advantage of market opportunities. How should I word this? Try to take advantage of market opportunities. Exploit small price discrepancies. And having higher amounts of capital to invest means more price impact that can mean greater price impact. So that the would nullify market opportunity. I guess you could say saturate, maybe. Okay. Another important fees volatility of the underlying portfolio can have influence the amounts of fees paid. A portfolio of Okay, so I think this is a pretty good summary of what the authors had to say. We'll get down to the conclusion. The authors suggest that this contributor to why high water mark contracts exist, because hedge funds can't grow their aim to grow as they need other sources of income to survive. Cool. So just that this may encourage hedge fund managers to increase the amount of risk in their strategies. Okay, I think this is pretty good. All right. So now I'm going to work on the second part about the actual model itself. Okay, we have oh shoot. I keep forgetting that the screen freezes every time I start this stream, so sorry you can't see anything. Okay, there we go. Alright, so we need to find the present value of the fees given these. Yeah, so what is S and what is H? Right, that's what we need. Oh, I see. Let's just try S divided by H is 1. So let's say this is 1. S, H. Sigma by H, R, sigma, K, C, C1, G, W, lambda, B, gamma, N. Ooh, okay, so I am not getting the right number, but yeah, it's not even close. So it should be 33%. I'm getting 44. Okay, let's try to troubleshoot our code then. Let's see what's going on here. So this seems to be right. K times W plus lambda plus C times B to the 1 minus N times N times K plus K minus 1. I feel like this should be good. So I guess we could tell if the roots are right if we use that to find the present value of the performance fees. Performance fee. So S over H. I think we need gamma N K B. Right, so W1 numerator, W2 denominator. So this is, we need S over H. When we divide that, we raise this to the gamma minus 1, subtract B raised to the gamma minus N times S over H to be gamma n minus 1. So we have gamma times 1 plus k minus 1 minus b raised to the gamma minus n times 1 plus k minus 1. So we return W1 divided by W2 denominator. Then we multiply this by k. Print present value performance fees. I think we do 1 gamma n k b. Syntax error expected. Gamma is not defined. Oh, shoot. Okay. So performance fee is not even right. That probably means our roots are wrong. I think. Times gamma. Minus 1. Gamma minus n times 1 plus k minus 1 is over. Okay, what if we did n gamma? So n gamma. Okay, it's definitely not that. Gamma n. Get 8%. Same thing. Alright. So I think that has to do with how we found the roots. Oh, man. Also make sure that I have everything right. Oh. 0.015. There should be 0.03. Oh my god. Alright. I got the answers. Okay. Wait, so that's just a specific case when S over H is equal to 1. I think S is the net asset value, high water mark, and H is a high water mark. So I think if it's equal to 1, that means the high water mark is the S over H. Huh. I'm trying to think, yeah, what does this mean intuitively? Alright, as the value of your fund declines, so as S declines, then you have a lower chance of earning your fees. Because it's just really hard to get back to the high water mark. Okay, that makes sense. S in 1.9 MP dot A range 0.5 to 1.1.1. Line 15. Yeah. .1%, 27. All right, nice. Performance fees equal to total fee and then we have the total fee regular fee, so total fee minus performance fee. Okay. We have, let's do performance fee list is equal to performance empty list, and we also have total fee list is equal to, and then regular fee list is equal to an empty list, and then we just append each of these. Okay, actually I do have to go use the bathroom real quick, so I'll be back in a sec.
Really?
back. Came back. Let's see what we're working on. Okay, now I just have to iterate through all of the possible fractions, and then I'll just append them to the list. Okay, then we can model, let's say, import pandas as well, and just I'll smack everything inside the data frame. Alright, and then we can create a dictionary, so df regular fee, performance fee, fee list, and then we also have the H total fee. List PD to data frame, and then we pass in the data frame dict, and let's display df. Invalid syntax. Okay, I don't think we need this last one here. PD is not defined. Oh, shoot. It's a data frame, capital F. Oops. Okay, here we go. So it'll be 1.0 to 0.5. We could take a minus 0.1 step. Let's see if this works. Might need to go down. Okay, here we go. I think this is exactly the same. At least very close to being the same. Okay, we can use column is equal to 0. Set that equal to column. Set call index. I swear there's an attribute you can pass in that can allow you to use the index as one of the columns as an index. Pandas data frame. Oh, maybe that was in read CSV. Index is equal to S over H, maybe? Let's see. Okay, I see. Just leave it like this for now. So there's two things that we iterated over. For B in 0.5 0.8. So for sigma in 0.15, 0.25, 5. Yeah, we might have a quadruple loop. For W in, say, 0.25 by 0.025, and then 0.05, we have lambda is equal to W. Okay. Why are some of these longer than the others? Oh, I see. I do not think we want to do that. Oh yeah, we wanna reset this every single time. So print B is equal to B. Sigma is equal to sigma print W plus B is thus lambda is equal to W plus lambda. Yeah, this is weird. It's not. The performance fee doesn't change, it seems like. Should it change with? It should. W plus lambda. For sigma in okay. Now I think this should be right. 20.6. Okay, so I think we have all the charts. One thing from the pattern of the charts. These are fixed parameters that we do not change. Simulating. In the code below, I tried simulating the values of regular annual and so the annual and incentive fees. These charts are the same as these tables are the same as the tables in the table 1 in the paper. Okay. Using the model provided for finding the pricing. One, we have, I think, total fees to performance fees 3. Regular fees, I think mathematically this is FSH. ASH. Tables. The tables below replicate table 1. What I've noticed is that increasing the standard deviation of returns, sigma, some interesting observations. Okay, so there are some interesting observations. First, sigma standard deviation increases. So what does B mean? Okay, so some interesting observations. Sigma and increases in the standard deviation of returns. Sigma increases the fees when the probability of liquidation is 0, but when the probability of liquidation is more than 0, it decreases the amount of fees. Liquidation. But when the probability is higher than 0, higher sigma decreases the total fees. As the total net asset value, well, I guess it's the net asset value of the hedge fund declines, the total amounts of fees fall relative to the high watermark H. Yes. I think this makes economic sense. Okay, so it's also as the probability of liquidation increases, the total fee amount decreases as well. Despite total fees falling, the performance fee increases when probability of default is less than or equal to 0.5. Okay. Alright, that's nice. So I think I'm done with this. I'm not too sure exactly why this isn't printing above. Damn, yeah. What if we do print df? Display. Does that work? B is equal to 0. Okay, nice. I think we can then just bring all this over here. Okay, yeah, this is tough. Alright, so I think then this is pretty good. So I'm just going to turn this in, and then week 3B, extra credits, author Brian Zhang. Okay, so I think then you can take this and then export as PDF. Should be good. Break 3B, extra credits. I think I'll put that in. Okay, so that's good. In that case, I'm probably gonna end the stream here. I was able to finish that. I might do another assignment later, but I think I might study for an exam right now, so I'll have to see. But yeah, I'll catch you guys in the next one. See ya.